Okay, in this video we're going to do a problem from the e-textbook, page 398, and this is what it is. Top grade turf lawn seed mixture contains 3 types of seeds, bluegrass, rye, and Bermuda. The cost per pound of the 3 types of seed are 12 cents, 15 cents, and 5 cents respectively. In each batch there must be at least 20% bluegrass seed, and the amount of Bermuda seed must be no more than 2/3 the amount of rye seed. To fill current orders, the company must make at least 5,000 pounds of the mixture. How much of each kind of seed should be used to minimize costs? Okay, so this course is certainly focused on applications. Most of you are business majors, so this is the kind of thing that you really, the whole point of us learning the Simplex method and all this is so that you can handle problems like this. So what I want you to do is pause the video in a minute and just think about, first of all, what are the 3 variables, and what are the constraints, and what are we going to be optimizing? So go ahead and take a time to write the variables, write the constraints, write the objective function, and then when you're done with that, unpause it. Okay, so first up of our variables, I did use y's because we were asked to minimize in this problem. And so y1 would be the number of pounds of bluegrass seed. So when you're stating your variables, don't just say y1 is bluegrass seed. What do you mean about that? It's the number of pounds, okay? Because sometimes it's like in millions of dollars or thousands of quarts or whatever it happens to be. You want to really be specific. So numbers of pounds of bluegrass. Y2 would be for the rye and Y3 for the Bermuda seed. Now we want to minimize cost. So if you're going to write your objective function, you want to look through the paragraph and see what we want to minimize. So I'm going to call this W because we're minimizing. And notice that, let's see, we have 12 cents for each type for the bluegrass, 15 cents for the rye, and 5 cents for the Bermuda. So let's write the objective function. And I'm going to write it in terms of dollars because I sort of assume we're going to be spending more than cents. So let's write it in dollars. So I'm going to write 0.12 for y1 as my coefficient, etc. So here is my objective function. And now let's write the constraints. Okay, so the first thing I read here is that in each batch there must be at least 20% bluegrass seed. So out of the total batch, at least 20% has to be bluegrass seed. So when I think about the total batch, that's going to be the sum of all the seeds put together. So this to me represents the total batch that I have. And we're saying that if I take 20% of that, that has to be, so there has to be at least that much of just the bluegrass. So Y1, which is the number of pounds of bluegrass, Y1 has to be greater than or equal to 20% of the whole batch. So make sure you understand this constraint here. This one potentially could have tripped you up a little bit. All right, now let's look at the next sentence. It says, also the amount of Bermuda seed must be no more than 2/3 the amount of rye seed. Okay, so the amount of, let me read that again, the amount of Bermuda seed, which that's my Y3. So Y3 has to be no more than, or that's another way of said less than or equal to, 2/3 the amount of rye seed. Okay, so like that. And then finally, they tell us that the company must make at least 5,000 pounds of the mixture. So when I think about the whole mixture, Y1 plus Y2 plus Y3, I better have at least 5,000 pounds. So again, remember, this is why I wanted to clarify that my variables are in terms of pounds, so that when I have this last constraint, this is all in terms of pounds. So up to this point, to me, is really crucial. The fact that you can actually just write down the variables, the objective function, and the constraints. This is really key, because if you can't do this, then certainly you're not going to be able to continue this problem. All right, so now the goal, of course, is to turn all these inequalities into equations by introducing slack and surplus variables where necessary. But I do have a little bit of algebra to do here in this first constraint. So if I distribute my 0.2, so 0.2 y1 plus 0.2 y2 plus 0.2 y3, that's less than or equal to y1. Subtracting y1 over to the other side of the inequality, not equation, sorry. I'm going to have negative 0.8 y1 plus 0.2 y2 plus 0.2 y3 less than or equal to 0. Okay, and then the rest we have. So now let's turn these into equations. Okay, so when we write these as equations, I'm going to write these down here. I'm going to have negative 0.8 y1 plus 0.2 y2 plus 0.2 to y3. Remember, that's less than or equal to 0. So there's some potential slack that we need to add in order to get to 0. So there's a slack variable. This equation right here, I'm going to subtract the 2/3 over to the other side. So I'm going to have a negative 2/3 y2 plus y3. And again, because it's less than or equal to 0, there's some other potential slack that I might need to add here to get it equal to 0. And then finally, I take this third inequality here. So y1 plus y2 plus y3. This is greater than or equal to 5,000. So there could be some surplus. We're going to subtract off S3 to make it equal to 5,000. So now we take these equations along with the objective function and we write the Simplex tableau. So here's our Simplex tableau. Remember that W is equal to the opposite of Z, so these signs just stay positive here. Okay, now what we're going to do is write down the basic solution. So we see that y1 is 0, y2 is 0, y3 is 0, s1 is 0, s2 is 0, and S3 is negative 5,000. So our basic solution is not feasible. And that's because of this S3, this surplus variable. So we look at this column right here with the non-zero entry, and we look now at this row, and we choose a positive entry other than the 5,000, a positive entry in this row. So I'm going to always just go with the first one. And so this becomes my pivot column. And then I have to look at the quotients to determine my pivot row. When I look at my quotients, I ignore any terms that have a negative value. So, and certainly here, 0 divided by 0, I'm going to also ignore since that's not defined. So I just really have the 5,000 divided by 1. And so that's going to be my smallest term. And so my pivot row is going to be on this 1 right here. Okay, after one round of pivoting with these two elementary row operations, we see that we do have this pivot column as needed. And so now let's write down the solution again, the basic solution. So we get this basic solution that if we just do only bluegrass seeds, then of course we're not going to minimize costs, but it will meet all the constraints. So it is an actual, at least it's a feasible solution, but it's certainly not optimal. Right? In fact, because remember that bluegrass cost 12 cents per pound, so that was kind of a lot. Okay, so how do we know it's not optimal? Well, we have a negative indicator here. And so we're going to proceed into indicator, sorry, spelled that totally wrong. So we're going to move on to, so stage 1 is complete, and we're going to move on to stage 2, which is to perform the simplex method. So we look at this, hold on. Okay, so we look at this column that has the negative indicator in it, and we perform all of our quotients here. And so all of these are positive, so we look at all these quotients and we choose the smallest one, and so our pivot row is going to be the second row. So now again, let's pivot on this one and complete that next round of pivoting. So unfortunately, after this next round of pivoting, we still have a negative indicator, and so we have to repeat the process again by pivoting again. Do take note of the row operations that I just performed because we're about to erase that. So we now have a new pivot column, right? So we now, because of our negative indicator, we now want to pivot on the second column. And so we need to again look at the quotients. So of course, remember, we only consider the positive quotients, right? So we're not looking at the second row. And so we choose the smaller of these two quotients, which is going to be row 1. So now we're going to pivot on this 5/3. So first things first, we need to turn that 5/3 into a 1. So I multiplied the whole row by 3/5. Okay, so we perform these operations down here, and we get the next simplex tableau. And luckily, we have no more negative indicators, so that's good. So let's write down the solution. So y1 is going to be 1,000. This was y2. y2 is going to be 2,400. y3 will be 1,600. S1, S2, and S3 will all be 0, and we see our W value, which is negative 560, and of course W is equal to negative Z, so that tells us that Z is 560. And so our optimal solution would be to have 1,000 pounds of bluegrass, 2,400 pounds of rye seed, 1,600 pounds of Bermuda seed, and that's going to minimize costs at $560.